Okay, a very good morning to everyone, and I welcome you all to the seventh day of 10 days national level online training program on emerging trends in seed production technology and quality control framework for effective seed supply chain of horticulture crops. Now we have with us Dr. Dilip Masuti, Assistant Professor of Seed Science and Technology, Kituri Rani Channamma College of Horticulture, Harabavi, University of Horticulture Sciences, Bagalko, who is going to deliver a lecture on methods of seed testing in horticulture crops. Sir, on behalf of College of Horticulture, Bidar, and on behalf of organizing team, we are welcoming you for delivering lecture on allotted topic, sir. May I now
Thank you.
Dr. Ashok Suramsi sir to give brief introduction about Dr. Dilip Kumar Masuti. Over to you, sir.
Okay, thank you, Dr. Dhananjay. I'm very happy to introduce to Dr. Dilip Masuti. He is working as a assistant professor of seed science technology at College of Horticulture, Arbhavi. Coming to his academic, he is graduated from the Agriculture College, Dharwad, and MSc and PhD awarded from the same university. And afterwards, he joined as an assistant professor in seed technology in College of Horticulture, Arbhavi. In his professional of teaching in seeds technology, he motivated the students of diploma, UG, PG with a skill entrepreneurship with a seed production in the main aim. So he also supervised and advised the PhD, MSc students, and also contribute more than 60 research papers, abstracts, and chapter in different books in international and national journal of. Then as part of the research activity, he also involved with the development of suitable technology and production of seeds and planting material, which will boost the socio-economic status of the farmers. His research contribution has yielded in the technology adopted by the package of practice of the university. He has delivered more than 250 oration or speaker to the farmers, scientist, or agriculture officer, and invited talk from the KVK, training centers, extension units, international and national conference. So he is also recognized as a master of trainer and TOT, transfer technology, facilitator for farmers field school. Some of the recognition are, he awarded as a CAM fellow in the year 2009. He got a national fellowship MANF for his PhD. He also adjudged as a junior scientist for the year 2010, and in ISST Young Scientist awarded from Indian Society of Seed Science Technology, New Delhi, in the year of 2019. He's having a rich experience in the teaching, research, and extension. I hope this lecture is more useful for all the participants. With this brief biodata, I thank Dr. Dhaneja for giving me opportunity to introduce today's speaker, and over to the Dhaneja.
Thank you, sir. Thank you so much for introducing speaker to the participants. Sir, kindly start your presentation, sir. Over to you, sir.
It is okay, na? Audio?
Yeah, audible, sir. Audible, sir.
Yeah,
Please
okay. Thank you, Ashok sir. Thank you, Dhananjay. So first of all, I thank the University of Horticulture Sciences, Bagalko, for giving the opportunity, COH, Bidar, the Dean sir, Dr. Murugesh sir, Ashok sir, and Dr. Dhananjay for the opportunity. And good morning, everybody. So participants from the country as well as abroad. Okay, so allotted topic is methods of seed testing in horticulture crop. One of the important step in seed production. So all the steps from the point of quality seed productions, all are important from day one. That is again selection of area, suitable area, variety, the way of that we take up the POP for production, seed production, quality seed production, and then we harvest, we process it, we treat it. So all steps till marketing, these are important. One of the important steps is after harvest, the seed testing of the quality that is produced. So important one is, so we go for seed testing for mainly to know the genuinity. how pure it is, what is the status of the contamination, or what is the status of the health of that seed lot which is produced with a lot of effort. The farmer or the producer will have tons together, or maybe in quintals together, the seeds are being produced. The status of which has to be assured, or which has to be given a status that it is true and it is correct and it is having a worth to sow or plant in the next season for the farmers or the producers is most important, which can be again tested and given as a certificate in the seed testing laboratory. This is the important one, and we'll be having a knowledge over how pure it is, what is the pure live seed percentage of the seed lot which is produced. And apart from that, genuinity of the seed lot that I told, so that is also very important. So if we go with the things why we want these seed starts to be seed testing is to be done, and why what is the reason. So it is again to know the status of the planting value of the seeds which are produced, and again to assess the quality attributes. So quality is the most important one, important criteria that we take into consideration when we are going for the production. So this is the area, the seed testing, so which gives the status, what is the status of the quality seed that is produced. So again, when we are going for seed testing, there are plenty of aspects that we'll be covering. So mainly, majorly on the seed quality. So whether we are meeting out the required standard, minimum seed certification standard or not, that will be again tested in the laboratory, seed testing laboratories. So apart from that, we'll be also knowing the physical purity status, seed germination, genetic. We will be going for a GOT and all, and viability and vigor are the most important components that we'll be testing, along with the health as well as moisture. I won't be covering health because one of the speaker is also covering the seed health. So what is actually why, with what intention, what are the objectives of having this seed testing? So it is to test the suitability of this planting material in order to know the quality status is one of the important aspects that will be dealing, as well as the quality problems, so which are to be identified, and what is the probable cause for that. Again, we can give a suggestion for that, and along with that, if at all there is a excess moisture, so we can take up an activity again. We can get back to processing, and we can go for still drying, and we can come back. So these are all the important aspects that is required for the seed technologist before packing and selling. So the moisture content of the seed has to be in a minimum less than 15% of the 15% for most of the crops. So that has to be again assessed, that is known in the laboratory. So this is again quality to determine the quality standards. That is also for labeling aspects and all, it is must. So we'll be dealing these things, but before that, we'll try to have the history. So before the start of laboratory, seed testing laboratory, as of now, so we have a uniformity in all the laboratory all over the world. So we take a single measure, single steps. We follow the single protocol or procedure for the seed testing. Before that, when we started producing and when we started commercializing it, it was not there. Seed testing was not given much. The concept was not there. So in 1819, so some of the traders, they started bartering, or they started commercializing the seeds. Maybe they started moving the seeds from one nation to the other. Then there comes the concept of quality, that they are tested for the presence of wheat seeds. So that is again a nation may be acquiring, or a nation may be getting a wheat seed if at all that is the produce or the seed material, that is the consignment is not processed or cleaned properly. So in order to avoid, apart from the seed which is admixtured with the wheat, there may be chances of having some diseases. So new diseases may be attacking, or the new diseases may be entering to the nation, where it can spread, they can devastate the things. So in order to have the diseases, weeds, as well as a new introductory pests, so in order to control everything, we have to know the status of the seed produced, or which is exported or imported. So based on that, so this can be have a negotiation, or maybe it can be bartered or commercialized it. So the history says, so it was there only for the clove in early 18th century, but in Nobbe, we call the father of seed testing. So he started seed testing laboratories in 1869 in Germany. So that was the initiation of the concept of seed testing. And the clear-cut mentioning of seed testing importance was again written in the Handbook of Seed Science in 1876, so which has given much importance for the seed testing. So in India, if you see, there are not much importance was given before the independence, but in second 5-year plan, we could see some of the laboratories were established in India. So again, there were 4 laboratories in IRA subcenters established in the second 5-year plan. So in later part, when seed acts were come, it has introduced, enacted, so that it has made a mandate for all the states in India should have their own seed testing laboratories. So this has given a boost for seed testing in the country. So there are plenty of organizations which are associated with the seed testing. So because uniformity is the one that we have to have, we have to give utmost importance in all over the world. So with that concept, this 1924 law, so International Seed Testing Association, ISTA, this has started. It has started developing the procedure protocols for uniformity in all the laboratories. So later part, AOSA is the one. So that is also related to the analysis of the seed testing procedures. So what is the role of the seed testing laboratory? So it is laboratory tests only the sample that is received, the material that is received to its laboratory. It is assessed what sort of percentage of the purity status or contamination it is. It is not to upgrade any sort of seed lot that is there. It is to tell what is the status of the seed lot that is produced, maybe in bags, containers, etc. Is to tell only the status, not to improve the quality. A technical session that will cover the analysis of that purity status, varietal purity, maybe will be going up to the GOTs. We will be also testing for the seed health as well as important ones, germination along with the moisture content also. So the machines which are there in the laboratory, in the seed testing laboratory, should perfectly, they should give the result very well. If at all your machines are not performing, the results will be something disturbing, or something it is not up to the mark. So that is the indicative that the lot which is produced by the farmer or the producer is not up to the mark. So the indicative of the results are the indicative to the results to the lot that is produced. So we have to have the accurate machines, and we have to have the uniform procedures, and correctly we have to do the seed testing procedures. We have to adopt the uniform seed testing procedures. So what we'll be doing? So we'll be focusing on many things in the seed testing laboratory. So one of the important thing is seed sampling. So we have to draw a uniform and a true representative of the seed lot. We have to take, we cannot take plenty of bulk into the laboratory and test. So we have to have the representative of the seed lot or the seed produced. So the bulk seeds that will be taking a true representative and will be sending to the STL in order to know the status of that total lot. So we'll be also doing the purity analysis. We'll be testing for the germination, and we'll be studying for viability by some biochemical tests, and also testing health status, the presence of any diseases, and all. Vigor also will be determining, and moisture content, everything will be knowing along with the GOTs at the end. So I told the sampling is very important. So the sampling decides your lot's performance. So if at all you are taking the sampling, something it is not as per the rules, or if at all your sampling procedures are a failure, then obviously the results will be the indicative to the total lot. It may be rejected also. So in order to have, so we have to have the sampling procedure accurately, we have to perform. So it is to get a true representative of the bulk that is produced or that is stored. So when we are sending the sample, so we should send along with that, we have to send some of the information like name and address, who has taken. There are officials and there are different types of samples that will be taking and will be sending it to the laboratories. And some minimum things that we have to mention is the name and address, kind of the seed and variety, year of harvest, type of the test required. Maybe we'll be taking only, if at all you want to know the viability, germination test, you have to write only germination tests are required. So approximately there will be some cost incurred, or they'll be charging some charges for the test of individual, or maybe in a collective also. So these are some of the equipments which are required to draw or take the sample. Maybe we'll be using some betrayers. So we'll be taking. So we have to have the uniformity in the sample. So you have to take the representative sample from all the parts of the bags, bins, or the heap, whatever it is. So we have to use the Nobbe trayers, so that will take the representative samples, or the samples each from each part. And if the sample is very bulky, or if it is taken at a larger quantity, then it can reduce. Scientifically, we have to reduce by using some dividers. So we have plenty of different dividers. And then we'll be testing for some of the quality status like physical purity, and we'll be testing, and we'll be taking some count and moisture content. These are we'll be having a germination. That is the important one, which gives the results. So again, how to take the sample? Again, I told it is from all the bags. So from all the bags, the true representatives. So that you are collecting from individual bags. So that is, there is a chart that will show you. So samples are collected from the other bags, and it is again bulked. So the primary samples are bulked. That is, again, we make the composite sample, and then we'll be submitting it to the STL for analysis. So from submitted sample, we'll be taking again some working sample for individual analysis of maybe physical purity or germination, moisture content, etc. So in submitted sample, so in official procedures, we'll be drawing 3 such a representative sample. That one will be sent to STL. The other will be given to the dealers or the producers, or who will be storing the seeds, and one will be kept by the official who has drawn the sample. So that will be again called the GAR sample. Okay. Then I was telling the sampling intensity. So if at all we have the containers 1 to 4, so we have to draw the 3 primary samples from each containers, and if at all it is 5 to 8 like. So this is under the procedures are written, and these are all written in seed rules that we have to follow accordingly, and we have to go ahead with. Or we cannot just simply we cannot take our own measures to draw the sample and send. So this is how, again, if it is in seed lot up to 500 kg, at least 5 primary samples from all parts of that lot. And if it is more than 500, so 1 primary sample from 300 kg, but less than 5 sample, like it is written. So along with that, so we can have a sample, submitted sample. This is the quantity that you can submit. So from 25 gram to 1 kg also we can submit. We are supposed to submit the sample. Minimum of this quantity you can submit. So with this submitted sample, we'll be taking a working sample. Maybe if it is in salary, so you can give submitted sample to up to 25 grams. So from that, we'll be taking 1 gram for working, as a working sample for knowing the germination test. Based on the size, so it is decided how much to submit. So in the seed size is larger, so you have to submit up to 1 kg as the submitted sample. So first important test that we'll be analyzing in the laboratory is physical purity test. Physical purity test, what is the status of the pure seed percentage? So most of the crop cities, as per law, it is around 98% is the physical purity status. That again depends on the class of seed. That is again foundation or certified seeds. It depends on. So again, apart from that, so we'll be having also taking for the presence of inert matter. So if it is 98% as the pure seed sample, so rest of the thing is the other part, that is the this one, inert matter. The 2% will be inert matter. So that may include your all other chaffiness or broken seeds, maybe eat seeds. So all put together, that will be inert matter that is considered. So we'll be taking the sample for the test of these things in the laboratory. Okay. Then physical purity analysis by weight. So again, we'll be calculating these 4 components by weight. So how much quantity of the seed fraction it is to the pure seed. So we'll be first thing, so we'll be doing in the laboratory the analysis of physical purity. So the pure seed fraction which is extracted out of this one is taken for the other analysis of other parameters. So it is again, the procedures are again followed as per the seed rules. So you have to have the minimum decimal that has to be compulsorily, that we have to have that has to be followed. So again, we have to convert that one into percentage, or if it is in count, maybe for other crop seeds, if it is in count, we have to tell how many seeds are there per kg of seeds that you have to mention in the your label, that we have to mention in the label. That is the one. So I told as the minimum seed certification standard for physical purity percentage by weight. So again, I told it is varying with the crop as well as the cross. I told it is 95% to 99 for our okra and all. We have to have minimum of 99% as the pure seed fraction. Okay, then determination of other seed by number. So other seed maybe including the other species, maybe not CS1, maybe if at all you are specifying, if at all any the sender has specifying, so identify the other crop seeds. So again, we have to go to test, or to bifurcate, to eliminate, or to count the other crop seeds by number. Again, this is again done on the physical purity board. So individually we'll be taking the working sample and will be bifurcating into pure seed fraction, other crop seed, inert matter, weeds. So it is done in the laboratory like this. Can someone remove that lines again done?
Sir, just close it and reshare it, sir. Dilip, sir, someone has made it. Just close and reshare it, sir. All the participants are requested to not to draw any annotations on the screen.
Sir, remove the person who is drawing lines, sir. It's disturbing the class.
One minute.
Sir, share your screen, sir. Dilip, sir.
Yes. Now it's okay, na? Dhananjay, is it okay?
Yes, sir. Yes, sir. Now it is visible. Just directly go to your slide, sir.
Yes. Okay. Again, this is again seed certificate standard for number of other crop seeds that I was telling. So how many seeds are there as an other crop seeds by number that you have to mention in the label. So again, the total number of weeds also we have to mention per kg of seeds that is sent. Again, seed certification standards for number of objectionable weeds for some of the vegetables that I have highlighted here, and this is for some of the spice crops. So pure seed fraction, how much it should be for foundation as well as certified. Inert matter, how much should be the maximum percentage? Should be 2%. It should not cross 2%. it will fall under substandard category if it is crossing 2%. So again, other crop seeds, maximum it is for foundation and certified, and total wheat seeds and germination and moisture content percentage. So this is for seed spices. So again, the immediately after the physical purity, if at all we are requesting for germination test, it is the most important one, which gives the status of what is the status of the that lot which is produced. So we do germination test in the laboratory. So the minimum specified quantity is around the minimum of 4 application of 100 seeds. 400 seeds we require to do the test. So again, unbiased and the true representative seeds are taken and put it in the there are 3-4 types of test we'll be doing in the germination for assessing the seedlings. So how much percentage is the germination in the laboratory. So again, we'll be calculating, we'll be evaluating the normal seedling, the abnormal seedling, hard seeds, and the fresh ungerminated and dead seeds. These are the 5 types of seeds that will be letting in the tests, and will be telling the results. And these are essential seedling structures. So normal seedling, you should have a proportionate development of both root as well as shoot. So let me have one example that I have. So we have passion fruit. So it is again showing a proportionate development of root as well as shoot. So this is the one that we can have a normal one. So if it is abnormal on any one of the part, maybe root or shoot, it is again deformed, or it has not developed into the appropriate length as per the as of the other. So we can have the seedlings of other crops which are shown. So let me show this one, areca palm. It is also showing the equal proportionate of the growth of root as well as the shoot. So this we can consider as a normal seedling. So when we are doing these things, doing the test, so we'll be also coming across with some of the dead seeds. So which are almost, they have taken, imbibed the water, moisture content in the laboratory, and they have not executed their they have not evolved the plumule or radical. So again, this is again we have we'll be categorizing into dead. So apart from normal seeds, we can see dead one and abnormal. Any one of the part is missing, or it has deformed, or it has not grown properly. So that is again abnormal. Hard seeds. So because of the seed coat, maybe the hardened seed coats, the seeds, though viable, they may not have the capacity to imbibe the water and give plumule as well as radical. So that is again hard seeds that we categorize into. So that is again damaged seedlings that again if at all the parts are even broken or missing, so again damage will be. So if it is disease infected, or maybe because of the moisture, higher moisture, so decayed seedlings, again I told because of the hard seed coat, again hard seeds will be the other category. The fresh ungerminated, so this will be having a imbibition of the water, there will be a fuzziness, but that won't perform, that won't give plumule or radical. So that is again fresh ungerminated categories. So we have minimum three types of germination test we'll be doing, but pleated paper is also one of the tests we can have it, apart from top of the paper, between paper, and sandpaper. So the categories of the test, it depends on the type of the seed, the size of the seed. So again, if it is smaller seed, we can go on the paper. We can grow these things on a petri plate like this. And if it is the seeds are bigger one, so we can go between the paper and between the two paper. So we call paper towel. So we'll be rolling that one. And if it is still bigger based on the size, so we can go with the sand also. So sterile sand also we can take, and we can grow the things like this. Okay, and this is again based on the size of the seed we decide which type of seed test we have to go. So there are specific requirement before the test. So we have to, for some crops, we have to go for some pre-treatment. So maybe pre-chilling is the treatment that we can go for beans, cold crops, and all. Preheating for 35 to 40 degrees Celsius for 7 days in Chile also we go. And then again, light is for some crop it is required. So before germination, standard germination test, we are going for the pre-treatment test. So, so this is one the table that will be representing the requirements of different crops. So we'll be taking, we'll be keeping the seeds in appropriate and congenial environment. So we use the standard procedures is we have to keep these things in a germinator. So where we'll be keeping the constant temperature around. For some of the crops we use the substrata as an between paper on top of the paper, so with a temperature of around 25 to 20 to 30 degrees Celsius, and we'll be keeping these things for 7 days to know the status of the germination for initial 7 days, that we call the first count. So almost 50% of the germinations are to be happened by 7th day. So at the end, we take the final count, that is on 14th. So end of the germination test. So at that final count, we'll be taking the results for germination, seedling length, and everything will be calculating at the final day, and we'll be representing whatever the germination results are. So this is again the substrata based on the crop I told. So that is different for different crops. Again, it is in some of the spice crops. The light requirements are for celery, and the temperature range is around 20 to 30 is the common temperature that we maintain. So, but first count and second count, it varies with the crop to crop, that is there. Okay, then the first count, it varies from 4 days to 10 days. That I told. So for some it is 4 days only. In sugar beet and all, we take the 4th day the first count, and for some celery, and so that is on for 10th day. So and the final count also it varies up to 28 days we will be taking. So for some it is a short duration. I mean, let us start within 7 days we'll complete the germination test and we'll be giving the result. So that varies. The final count varies with the crop, and it is the uniform procedures are mentioned in ISTA procedure. Will be following the international standards. Again, so I told some of the seeds they require only top of the paper, some between paper, some the combination of, and you can have for cucumber and sugar beet you can have TP, BP, and sand as the substrata. So that varies, I told. So this is again the seed germination standards for some of the crops. For FS, foundation seed is different, and for certified it is different. And this is the laboratory view where the testing will be done, and the analysis is again the recorded. So again nowadays, so we'll be also using automatic germination machines. So it will be taking the daily basis, on daily basis how much germination is and how the status, how fast it is growing, or what is the vigor or the length also we can calculate a daily basis. So that is also nowadays we are, so it is up to the ISTA, though we have to decide. The ISTA is not accredited for doing in the laboratory, because most of the laboratories won't be sophisticated with the instrument or the computerization of these facilities. So it has not yet officially, but we can use the germination like this, like that also. So next, bigger test. It is again bigger. We can say the viability is the one, the status of liveliness we call. So bigger is degree of the liveliness. Degree means how fast it is, how better it is. So you can have bigger test for comparison of 2 lots or 2 varieties. So that is again we can do. So how fast it is giving the results also can be tested. So bigger tests also there. And there are plenty of figure tests. So there are plenty of figure tests we take into consideration. There are physical tests, there are performance tests, and there are stress tests and biochemical. The stress tests are more important, so which gives the actual vigor, how it can perform. So you see, there are simple physical tests also, like seed density, seed size. Based on the density size also we can categorize the things. And the stress test, so important one are brick gravel and paper piercing, AA test, accelerated aging test we call, so cold test. So that is again very important with respect to. So in biochemical TZ test and EC, electrical conductivity tests are important. So these are the bigger tests that we can have. So this tells what is the how fast it is, the degree of liveliness is. Again, you can compare with the bigger test. So you can have the lots with the low vigor as well as high. Give the stress, so they will perform. So how fast it is, how much it is. So based on that, the lot can be decided. This is the best lot, or this is better lot than the compared to the vigor. So this is how we can do. So seedling growth test, again, the speed of the germination. While calculating daily basis, we have to take the germination, maybe shoot length and root length, and we'll be calculating the other parameters. Quality attributes can also be decided based on speed of the germination, seedling size, and diameter. So at the end of the test, the second count, so we have to take the reading for diameter, and we have to tell what is the strength of that variety or the lot or the sample that is sent. So there are some bigger tests like cold test I told. So that is also important, where we can have the pure seeds kept in between two soil layers of 2 centimeter each, and then we'll be watering it, moistening it. The temperature of the water is around 10 degrees Celsius. I moistened for 7 days. So then we'll be taking, and then we'll be going for the normal germination, standard germination test for these things. And we'll be seeing, or we'll be comparing the lots, how they are performing. So whether the lot A is performing or not, or whether the lot B is not performing. So like that we can compare, and we can tell the lots are having the vigorous or low vigorous based on the cold test. And accelerated test is the one, so where we'll be giving the higher temperature as well as higher relative humidity. So we were imposing, or we are creating an environment where the seeds should come in stress. So this temperature as well as higher relative humidity will definitely make the seeds to be in stress, and then with that stress also, if at all seeds are coming up well, so that lot or the seed performance is very good that we can create. So that is again, this is also a standard germination test, also vigor test that will be doing in the laboratories. So this is how we are doing. And there are some performance. So the research for this some crops like lettuce, eggplant, and broccoli, and these are all so these are tested almost very accurate with the performance in the field. So you give the accelerated aging test for these things, and you will be knowing the results. The performance is very good. Equally the same performance will be in the field. So that's what it is tested with some of the horticulture crops, right? Okay, then again the conductivity test also will be making. So will be the electrical conductivity is again, so if it is again indicated that if the seeds are stored for longer time, if at all you are storing the seeds for longer time, again there will be an the sap or the leachate from the shells of the seeds are coming out. The broken broken seed coats that will be giving a leachate into the will be again calculating or evaluating. So if the seeds are stored for longer time, obviously the shells will be giving out, the sap has come out, and there will be the conductivity of that. So the sap will be higher. So if the seeds are stored for longer time, if at all there is an substandard seeds or the storability is not good, then obviously sap will be coming out and the electrical conductivity will be very high. That is the indicator that the seed standard has gone down. So if the electrical conductivity is low, that is the indicator that the seeds are very stable and we can take up to sometimes for storage. So that is the indicative in the conductivity, electrical conductivity test that will be doing. And in peas, again, so there is an bias with the things like high vigor leakage in the peas. They have tested in the laboratory, may not be true in the field, in the special case with the peas. So it may be reverse. So they have tested high level leakage in the laboratory, but the performance is, so that is indicative that it is not performing well in the laboratory. But so in the field, so it has performed well. So there are some specifications, specific things for specific crops. So this is a concept like a seed vigor imaging system nowadays in the USA and all they are doing. So this is again bigger percentage we'll be calculating. So some of the works on the radish seedlings that they have done. And so this is everything it went goes with the software that is again developed. So this software again tested by some of the scientists and SOCO and co-scientists with the lettuce seed, and many things have happened with the corn, soybean, and sweet corn, okra, and all. And this software is an efficient alternative to assess the physiological potential of the some of the crops, and compared to traditional vigor tests. So they have almost, I have shown one of the earlier slide. So they will be assessing daily basis how the seedlings are growing. Daily basis will be assessing. So you can see the upper line with the seeds. Only 2 seeds have not germinated. Rest of the things they are giving better. So the bottom, so again we will be seeing around 5 seeds they have not germinated, and the seedling length is also less. So this can be assessed in the computerized version in digitally. So we'll be knowing what is the vigor status. So how much vigor, that index can be calculated automatically, and will be doing justice. So the lot or the variety that is sent are how they are differing, how they are performing individually are. So this is again computerized versions that nowadays we are going with testing the vigor. So this is also the same thing. So vigor index. So we'll be calculating vigor index in the laboratories by 2 means. But it is automatically, it is the images will be again captured by the computer, and it is giving automatically. This is also an improved version. In moisture test, so in the moisture test, we'll be taking a set procedure. So for sending the moisture, we have to have the seeds in a polythene covered bag, and we have to send without losing the moisture, and we have to send immediately to the seed testing laboratory, where we'll be testing for the seed. So if at all, so for some crop, if there is a moisture, excess moisture content, we have to dry for some time, and then we have to grind that one. For oil seeds, it is different. So we have 2 types of temperature set for oily and non-oily seeds. So if it is high oil content, so we have to set up the low constant temperature. If the oil percentage is less, so we have to go for the high constant woven method. So that is again we follow. So again we take the sample, we have standard set procedures. That is again low constant temperature woven method. So 103 degrees Celsius plus or minus 2 for 17 hours. Again for the high constant temperature woven method, for 130 degrees Celsius plus or minus 3 degrees for 1 to 4 hours based on the type of seeds. So again, this submitted sample will be taking moisture proof containers, and will be weighing that one. So initially, and we have to do these things. For some we are grinding, or for the seeds, you can keep these things in containers, so standard containers. We have to weigh that container as well as the seed weight, and we'll be taking the weight, and we'll be keeping with these 2 temperatures based on the seed, depending on the seeds, and then will be after that the times after that period. So we'll be taking out again. We'll be weighing. So what is the difference between the weight of that initial to the final is again counted. So eliminating that container's weight. So that is again how the we'll be doing. This is though it is a traditional old method, but still most of the laboratories to be, because we have to have the uniformity all over the world. So all the laboratories we still follow the method that will be, again, we will be using hot air oven. Okay, then nowadays we are also having some of the automatic seed moisture analyzing equipments also. So, but again, the standard one is, again, we are using the hot air oven method. Okay, then this is again modified low constant temperature oven method for some of the crops that I have highlighted, and high constant as well as high constant temperature oven method for some of the crops. Again, then minimum seed certification standard for moisture percentage, that again, for the sample in vapor proof container, if at all you're packing the seed sample in vapor proof containers, then there will be high moisture content. If at all you are packing the vapor proof, then the 1 or 2% will be less than the normal one. So that is the indicative that so we have to store the lower moisture content percentage when you are going for the vapor proof containers. Okay, then this is the one we will be using in the laboratories, the ovens, the containers in the keeping in the ovens, and the moisture. So we will be using analytical balance for knowing the moisture content percentage. So some of the viability studies tests that will be taking. So again, I told TZ is both viability and vigor that will be calculating. So this for viability, we call TZ test as an topographic. So TZ is a tetrasodium chloride or bromide is a solution which is again which represents the living shells. So if it is respiring shells, so this will react and it will give a change in the color. So we'll cut open the seeds and we'll be keeping this TZ over that, and we'll be seeing for the change in the color. If the change in the color is entire thing for the total seed, it is treated, it is very good, and it is having all shells living. So if it is only in some part, so somewhat it is not. So wherever it is required, so we can use the TZ is the quick test, and we will be representing the topographic as well as viability, how much percentage and what sort of vigorous is also known based on the topography of this one. So that is done in the laboratory with 1% TZ solution. So we'll be keeping the seeds, pre-soaking of the seeds in water for one day, and then we'll be taking out and we'll be cutting. So cutting those things, exposing the embryo part of the seed to the TZ, and we'll be keeping for some time, and maybe 30 minutes, 1 hour, and then the topography or the dilution by this one because of the TZ is again calculated. That is the indicative that the shells are leaving, the seeds are viable. So this is again we can see the embryo portion is red. So that is most important, that the living shells are present at vigorous, and some seeds are some seeds with only decay stained with the only plumule. Then there is no radical portion. So this is also will be maybe think it is not up to the mark that the performance of the seeds will be, and some they don't stain at all. The red colors that you are not seeing here. So that is again almost dead cells we can call. Some seeds are because of the heat. There is an indicative that the shells present inside are damaged, are dead, and the rest of the things it is reddened. So that is again because of the heat. So that is happened. So this TZ test will tell the quickly the viable liveliness of the seeds that is again submitted. So again, it is also in bell pepper, the embryo portion staining will tell how the viability and vigor status of the seed it is. So there are some tests like ferric chloride test for mechanical damage in legume crops that we will be doing. So that is also a test, additional test to know it. So the tests in the laboratory are done to know the exact the status. What is the status of the lot? So we'll be doing all these tests based on our uniformity, the ISTA standards which is again maintained, and every year, every month there will be an update with the crops, the test for the results for so and so crops are again modified. So again, it is to get the lots performance, the seed production program. If at all we want to get the good quality seeds, it has to be tested, it has to be labeled. For labeling and testing, so this uniform procedures of seed testing are followed in the STLs. So that is with the things for my presentation. Anything?
Thank you so much, Dr. Dilip sir, for your nice presentation on seed testing methods in horticulture crops. With the permission of speaker, now this session is open for discussion. If any questions are there from participant side, means you can just unmute yourself and you can ask.
Hello.
Hello, sir. Yes, sir.
Sir, germination test methods you said that 4 methods you said.
Yes.
For third one PP method.
Advanced?
Can you explain about that? Third one PP method.
TP, top of the paper. So we'll be using
not the top of the method.
Which method?
Something.
Huh?
PP. Third
PP.
One. Pleated paper method.
Pleated paper method. That is again with the germination. This is again germination paper. We'll be pleating it. We'll be making this one zigzag shape. We'll be folding. So this is that you are seeing. This is pleated. So in zigzag shape. So we'll be folding the germination paper and we'll be keeping the seeds in between. You are seeing at the top now. So this is again we are making pleats. We call it is pleats. So we will be keeping the seeds in and we'll be giving all the things, rest of the things, the standard this one temperature, relative humidity in the this one germination chamber, and we'll be keeping it. So same thing, it is pleated. It is not for all the crops. It is only for few crops. It is again tested. So please, you are seeing the seeds here they are kept and it is again taken for the top. Okay, that is pleated. Pleats.
Thank you, sir.
Good afternoon, sir.
Good afternoon.
Dr. Sumit. Sir, very nice presentation, sir.
Thank
sir,
you.
I want to ask one question.
Yes,
sir,
yes.
During calculating the speed of germination, sir, we are facing problem in case of BP method.
What is?
Between paper method while calculating the speed of germination.
Okay. It is very difficult. Yes, it is very difficult. It is very difficult because every day you cannot open it and you cannot close it. So the total length will be disturbed. So what we will be doing is we'll be keeping the seeds on a paper, and over it we'll be placing a glass over, and we'll be again putting that rubber band and all that, you know it as a standard thing. So we'll be taking these things as a standard one. But before that, so after keeping the seeds, and we have to keep that glass piece, and then that we have to take the observation. We have to keep 10 seeds or 15, 20 seeds on a line, and then daily we have to take the observation. That will be easy process to know the speed. Or else, as per that standards, we daily we cannot open up and see, so damage problem will be there. So that you can do.
Okay, thank you, sir. Very nice presentation, sir.
Thank you.
And more informative also, sir.
Thank you.
Thank you.
Good morning, sir.
Good morning.
Sir, I am from HAU and I have a query with respect to this seed testing method.
Yes.
Sir, I want to ask.
Yes. Yes. BHU. Yes. I'm not getting your voice. Hello?
Hello, sir.
Yes.
Am I audible, sir?
No audible.
Sir, okay. I want to ask, in some books, fresh ungerminated seeds are mentioned. So
okay.
how these are different than the hard seeds?
So hard seeds, there won't be any imbibition of the water inside the seed. So this is hard seed coat. Hard seed coat will be there. So though maybe embryo and sperm are very good, active and all inside, because of that hard seededness, because that coat, so there won't be an entry of the water. But fresh ungerminated, that will take the water. Because of the embryo is not performed well, that will again decay, and there will be fuzziness at all. So that will be the thing that you can have. Their hard seeds they won't take the imbibition of the water. The fresh ungerminated, that will imbibe the water, but they won't perform well. They won't give up because of the decaying things inside the.
Sir, my question is that in one crop there may be the hard seed or the fresh ungerminated both, or these are the crop specific?
No, sir. It may be there. Both the things are there. Both hard seededness, maybe because of the environment, the seed coat will be converting itself into hard seededness. The fresh ungerminated, it is maybe some there will be an rupture or maybe then opening in the seed coat, and that through that the seeds may be imbibing the water, and that will convert into fresh ungerminated because of the some malfunctioning in the embryo or endosperm. So that will imbibe. Maybe the seed coat may be ruptured somewhere else. So you may be getting both the things in the single test. No problem.
Okay, sir. Okay. Sir, I want to ask one more question, sir.
Yes, yes.
Sir, in seed testing laboratories, we should follow these ISTA rules, or we have this ICR seed testing handbook?
No, sir. We are following ISTA standards only. We are almost the ICR standards. So almost equivalent to ISTA standards only. So we want uniformity in the laboratories. So we follow because our consignments are being exported to their consignment. Almost our tests and their ISTA standards are almost equal. Nothing specific differences are not there. But if at all the consignment or the seeds which are being imported, if they specify you go with these things, so we have to have there are some ISTA laboratories also. I told there are around 124 our seed testing laboratory in the country, and there are 2 central seed testing laboratory, and there are 6 ISTA laboratories, ISTA standard laboratories, where they will be specifying for specific procedures. That only we have to do.
Okay, sir. Thank you, sir. Thank you for the nice lecture.
Thank you. Hello, sir.
Sir, good afternoon. I am Dr. Basuraj, ARS Madanuru.
Sir, Dr. Basuraj.
Farm Superintendent, I am talking.
Sir. Namaste, sir.
Sir, this potato, any certification standards, sir? Potato seeds?
Potato seed, TPS, we have the certification standards. As such, this bulb. So, pardon, sir? Basara, sir. Hello. Sir, Basara, sir.
Hello.
For TPS, we have the specific standards. As such, for the bulb only, it is again laboratory. Recently there was a case. So only storage was the problem. Because of the storage, there was a delay in delay in, and there was the poor germination in the result in the field. When we went there, and there were only for the TPS we have the procedure, but there were no such procedure for the bulb, the tuber that we use as a seed and planting material.
Okay, sir.
Okay.
Okay, thank you, sir.
Thank you, Basra, sir.
Okay, if there are no further questions from our participants, means now we are going to close this lecture. May I now invite Dr. Ashok Suramsi sir to propose vote of thanks.
Okay, thank you, Dhananjay. It is my privilege to propose the vote of thanks to today's speaker, Dr.